All right, today we're going to dive into this really cool AI idea that, honestly, sounds more like a story about a master art forger and a detective than some dry computer algorithm. We're talking about generative adversarial networks. So let's just jump right in with the big question, right? How do you actually teach a machine to be creative? Not just to recognize stuff, but to make something totally new, something it has never seen before, but that looks completely 100% real? Well, that's the exact problem that led to a huge breakthrough back in 2014. The solution they came up with was, well, it was basically a duel between two different AIs. So let's meet our two main characters here. You've got the forger, whose entire job is to create the most convincing fakes imaginable. And then you have the critic, whose job is to become an absolute expert at spotting those fakes. This constant battle, this conflict, that's the real engine of creativity here. And this whole idea, it was all laid out in a truly groundbreaking paper in 2014 by Ian Goodfellow and his team. What they proposed was a totally new way to build these kinds of generative models. They weren't using all these super complex statistics like before. Instead, they framed it as a competition, a game of deception. Okay, so let's get to know these two players a little better. Now, in the actual paper, they're not called the forger and the critic. They've got more technical names, the generator and the discriminator. But it's their competition, their rivalry, that makes this whole thing tick. So first up, you've got the generator. Think of this one like a team of counterfeiters. It literally starts with just random noise, like TV static, and its whole job is to try and turn that static into something that looks like the real deal. Could be a handwritten number, could be a human face. Its only goal is to fool its opponent. And then on the other side, trying to stop the generator, you've got the discriminator. This is our detective, the police force. It gets shown a mix of real pictures from a data set and the fake ones from the generator, and it has to figure out which is which. Its only goal is to sniff out those fakes. And this, right here, is the magic of the whole thing. The paper puts it just perfectly. This constant competition forces both AIs to get smarter and smarter. The forger gets better at making fakes, which then forces the critic to get better at spotting them, and this just keeps going, back and forth. Okay, so how does this game actually get played? What does this training process even look like? Let's break it down. You can think of it like a high-speed training montage for our two AIs. So here's the loop, simplified. It starts with the forger just making a whole batch of fakes out of that random noise. Then, the critic gets shown those fakes all mixed in with real images. The critic makes its call, gets feedback, and learns from its mistakes so it gets better. But here's the crucial part. The forger also gets feedback, and it learns which of its fakes were good enough to fool the critic. Then you just do it again. And again. Thousands and thousands of times. Now you gotta understand, at the very beginning, the generator is, well, it's terrible. The images it produces are just garbage, total noise. The critic has the easiest job in the world because the fakes look nothing like the real stuff. But here's the cool part. The generator learns. It gets a little signal back from the critic. You can think of it like getting a hint, a little direction, telling it how to tweak its fakes to make them just a little bit more believable next time. And slowly but surely, it starts to figure out the real patterns. But of course, as the forger gets better, the critic's job gets a whole lot harder, right? So it has to level up too. It gets sharper, learning to spot even the tiniest, most subtle flaws. And it's this constant pressure from the critic that really pushes the forger to create something amazing. So, what's the end game here? You'd think the whole point is for the critic to get so good it always wins, right? Well, nope. It's actually the exact opposite. The system is considered a success when the critic finally loses. Okay, so the fancy term for this is a mini-max game. It's a classic two-player, zero-sum game. One player's win is the other's loss. The generator is always trying to make the discriminator mess up as much as possible, while the discriminator is trying to make as few mistakes as it can. It's like this perfect mathematical tug-of-war. The whole system is basically done, it's reached its goal, when the generator's fakes are just so good that the critic is totally stumped. It just can't tell the difference anymore between what's real and what's fake. And how do you know when you've hit that point? Well, you know you've succeeded when the critic's accuracy drops all the way down to 50%. I mean, it's literally just guessing at that point, like flipping a coin. And that's when you know the generator has truly learned the essence of the real data. It has learned how to be creative. So, the big question, did it actually work? Oh yeah, absolutely. Just look at some of these results from the original paper. These are handwritten numbers, generated completely from scratch by the AI. These aren't copies of anything. They are brand new creations that look just like the real thing. And it wasn't just numbers. They also trained it on the Toronto face database. And again, just look at these. I want to be really clear, these are not real people. These are faces that were completely imagined by the generator, built up from nothing but random noise. And they didn't stop there. Here are images it generated of things like cars, airplanes, and animals from another data set. Now, they might look a little blurry to us today, but you have to remember, back in 2014, this was mind-blowing stuff. Okay, so why was this such a game changer? Why did this one paper basically kick off a revolution in generative AI? It's because it gave us a fundamentally new and way better way to train these kinds of models. This table really lays it out perfectly. See, before GANs, if you wanted to generate new images, you had to use these really complicated, slow, step-by-step methods that often gave you pretty blurry results. GANs just threw all that out the window. They used standard training methods that were way simpler, and the payoff was huge. They could produce these incredibly sharp, realistic images. So, to wrap that up, the advantages of playing this adversarial game were just massive. Training got way simpler and faster. And because the generator was being forced to learn and adapt instead of just copying things, it got really good at capturing the true underlying patterns in the data. The whole idea was so flexible, it just opened the floodgates for a decade of new research. That's why it took off like a rocket. And you know, that really brings us full circle, right back to where we started, that simple, powerful first sentence from the paper's abstract. They proposed a new game, and in doing so, they basically changed the rules for everybody. So it leaves you with this really interesting final thought. In this incredibly clever game of AI deception, where a forger and a critic push each other to become perfect, who's the real winner? It's not either of the AIs, it's us. Because we end up with this amazing new tool to understand and even recreate the world all around us.